Hey everyone, welcome to my session at Open Source Observability Days. In the next 20 minutes or so, we're going to get a grip on your telemetry using the OpenTelemetry Collector. My name is Adam Gardner. I'm the lead developer advocate at Dynatrace in Asia Pacific. Let's get straight to it. So, what's the agenda for today? What problem are we actually trying to solve with OpenTelemetry and the Collector? I'll give an overview of OpenTelemetry, the project and the collector itself, and then we're going to run through the hands-on scenarios. So some basic setup with batching, we're going to enrich those log files with file and operating system information, set some log severities based on the content and also by default. We're going to enrich the logs based on key value pairs. We're going to add some key value pairs to things. And then we're going to look at how you can standardize your log lines, whether the developers have a too big backlog, or you've bought some commercial off-the-shelf tooling and you can't actually change those logs. We'll see what you can do with that. We'll have a look at some sensitive information removal. Either it's up to you, dropping or filtering the logs or redacting the logs. We'll drop low-value logs. This is a common one. We see, debug logs in production. How do we solve that problem? We'll look at log enrichment, adding ownership information to the log files as they flow through the collector, and then we'll extract metrics from logs. So sending in a log with some metric information or numerical information that we want to actually treat as a real number and store maybe in a time series database, and then we'll enrich the logs using CSV files, which are, although they shouldn't be, they're still pretty common in enterprises today. So the key thing I want you to take away from this session is the OpenTelemetry Collector is a must-have, in my opinion. It's a must-have component in a modern observability stack. So first up, what is actually the problem we're trying to solve? Well, in a nutshell, it's data. Too much data. So I'm sure we've all, struggled with this. The default is just to store everything, and really you need as much information as you need to solve the issue and no more. No less, but no more. And often we default to just store everything just in case, and that can become prohibitively expensive. And putting the collector in the way can actually help that. So first up, OpenTelemetry. When people talk about OpenTelemetry, it's a lot of stuff. It's the instrumentation, the APIs, the SDKs, all of the code stuff that you add to your code potentially. And it's also the auto instrumentation. If you're working in a language like Java, OpenTelemetry can auto instrument some of those frameworks. It's the OpenTelemetry Collector. It's the OpenTelemetry Operator. It's OpAmp, the OpenTelemetry Agent Management Protocol. So if you're managing fleets of what they call agents, basically fleets of collectors, that's a protocol to be able to manage those collectors at scale. And it's also the semantic conventions. So if I'm talking about a virtual machine and I need to give it a host name, you and I need to standardize on the key, what we're going to call that. Otherwise, I call it host.name and you might call it host_name. And then, our two systems can't talk to each other. So that's the OpenTelemetry project do have a fully spec'd out semantic convention for everything from, as I say, virtual machines to AI to databases to pretty much anything you can think of. Now, today we're only going to focus in this session on the OpenTelemetry Collector. So, when we think about the collector, it's a component, a binary that runs basically between your data and your observability backend or backends. So you obviously want to get that data somehow from where it is into one or more observability backends. And what we do is we put the collector in the middle, and it can then process the data, and it gives you a lot of flexibility in that data that we'll see throughout today. So the collector itself has a number of components. For today, we'll focus on receivers, processors, exporters, and connectors. And we'll also touch on data pipelines. So receivers, as the name suggests, are how data gets into the collector in the first place. So your data is sitting out there, on a virtual machine or a Kubernetes cluster or somewhere, and it needs to get into the collector. So receivers are the way. Now, you'll notice that arrow is double-headed, and that's because depending on the receiver can actually open a listening port and wait for data to be sent to it, and you need to arrange to send the data to it, or it can actually reach out and pull the data in. Once the data is in the collector, we can process it in some way, shape, or form, and that's what the processors do. Then, of course, we need to get the data, once it's been munched and crunched and processed, we need to get it out of the collector and on its way to some sort of storage system, and that's obviously the exporters. Now the connectors, I've got little dashed lines there between receivers and exporters because they are actually both. They connect different data pipelines. Now the collector itself is configured via a YAML file, and what you do essentially is you build up these data processing pipelines in ways that you say, well, this set of log files is going to be processed in this way, and that is one pipeline, but my metrics or another set of logs is processed in a different way. We'll see all of that. It'll become clearer, trust me. And then obviously exporters, we send the data on out to our destinations, in my case Dynatrace, because I work for Dynatrace. So receivers, I've talked about them. It's the way you get data into the collector, and there are lots and lots and lots of them. Receivers, you can write your own, but to be honest, you're probably going to find one that's already written for you. As you can see there, operating system, statistics, monitoring log files, databases, cloud vendors, Prometheus, NetFlow, the list goes on and on and on. So I'd be quite surprised if you found something that you couldn't already monitor with an existing receiver, but you can use your own. And the short URL there that I've got on the screen takes you to a list of the contrib receivers that people have already built. Today we're only going to focus on log files, and hopefully that will give you a glimpse of what is possible, because we'll have many scenarios and just imagine what you can do with the rest of these receivers. Processors, as I said, are a way to process your data. That's filtering, redacting, detecting the resources, so where things are running, GeoIP lookups, CSV lookups, data transformations, masking, redacting, etc. Again, pretty much anything you can think of, there will be a processor to achieve that. We're going to touch on most of these today. And finally, exporters. There are, again, a number, but most vendors and observability backends, to be honest, have standardized on the OpenTelemetry protocol. You'll see that written as OTLP. So most observability vendors will accept OTLP data. Okay, let's get into the very basic setup and get our collector configured. Here is our log line in our file.log, and we want to get that into our observability backend. How? Well, it's actually quite simple. We configure the file log receiver to watch file.log. It's as simple as that. Now, this obviously assumes that the collector is running on the same virtual machine or host, in other words, laptop, whatever, as the file log, which in our case it is. The next thing we do is we use a processor, in this case a batch processor, and this is basically saying, look, watch these log files come in, these log lines, and batch them up in batches of 500 log lines, or if you get to 2 seconds and you haven't got 500, just send them on their way. So whichever comes first. Then, where are we going to send the data? Well, we've defined two exporters here. Debug, which is basically dump it out to the collector console, log output in detailed verbosity. Don't use this in production. It is very detailed. And send it to Dynatrace via the OTLP HTTP exporter. And then I can't count the number of times that I've messed this up myself, but the top section there doesn't actually do anything. They're just potential things that you know, receivers and exporters and things. The way you need to actually get this working is to build a pipeline. And here at the bottom, you can see we're building a pipeline for log data. The other options are, of course, metrics and traces. And we're telling the collector, please wire together the file log receiver, then process with the batch processor, and then export to both the debug and OTLP HTTP exporter at the same time. So we are multicasting to debug and OTLP HTTP, in this case a Dynatrace endpoint. And that bit at the bottom, that pipeline, is very important. If you forget that, nothing else is going to work. You won't actually get any data. But if you have that, you start up the collector and you should get your data in your backend system. Now, logs aren't very useful if you don't know where they're coming from. I mean, we're just sending my first log line, my second log line. We don't have any log status. We don't have any, by default, we don't have any information about where they're coming from. So here you can see that I've managed to add the host name, the log file name, the log file path, and the operating system type. This is very useful information because now I know where that log line is actually coming from, and actually the log file itself, where that is on that particular host. So how did I achieve that? Well, on the file log receiver, I added two parameters: include file name and include file path is true. And then in the processors, I defined a new processor called resource detection. And you can see there it's detecting using the system and actually looking up the host name of the system from the operating system APIs themselves. And then at the bottom there, don't forget to add this into your pipeline. Again, I've done it before myself a million times. If you add it to the top and not the bottom, you won't get any resource detection. Basically what this does, as log lines flow into the collector, it looks up the operating system information at runtime and dynamically enriches those log files for you, and then we batch them. Because ordering is important for these processors, so we first detect use the resource detection processor, then we batch them up and send them on their way. Now we're not actually defining any log severities here. We're just sending my first log line. So you can see by default the log level and status is set to none. But what I want to do is default everything to an info log level, like this. So I can do that using the transform process. And the transform processor, as the name suggests, transforms the log lines as they flow through the collector. Here, as you can see, kind of read these lines, these individual lines, read them backwards. That's the trick. So where the log severity text is empty, set the log severity text to info. So kind of a default to info. And OpenTelemetry has two severity fields, the textual field info and also a numeric field, a number. So again, where the log severity text is info, we're going to set the number to the correct numerical information. And the rest just happens. Everything is enriched, and all of your log lines are now at a info level. Don't forget to add the transform to the processing block. I'll keep saying it because I keep forgetting it. Okay, let's have a look at this set of logs here. My first log line, same as always, but then that fourth dummy log line, please investigate, something is broken. That's really critical that we can escalate that to an error level. Now imagine if your developer's backlog is full and they say, yeah, I can change that, but it's going to be 6 months. Or you've bought this software off the shelf and you can't actually change that log line at all. We need a way to elevate that to an error because we really do want someone to take a look at that. So this is what we want. We want everything to default to info as normal, but that individual log line, because it has that text, something is broken, we want to lift that to an error. We can do that. Those top lines are the same as before, but below that, we're actually looking for the string something is broken. Where we find that, we're setting the log severity to error. It's as simple as that. But this is, although it's simple, it's very powerful. Now you're in control of the logs. You don't need to go back to the developers necessarily to have a stopgap, or even if it's commercial off-the-shelf tooling, you can start to adjust log levels and severities as you see fit without changing the code. Now, let's have a look at this. My dummy log line from user ID 123, part of user tier equals tier 1. Now, we know organizationally that tier 1, let's imagine, is our gold standard tier. So this is what we're aiming for, the support tier to be gold. We don't want to add that mental overhead to our users and our SREs and whoever else is looking at this data to go, what's tier 1 again? I can't quite remember. Was that bronze or was that gold? Which way around was it? And also the alerting, the workflows, the auto remediation, every other system can then leverage that support tier as gold in whatever way it sees fit. So how did we arrange to do this? Well, we use the transform processor again. This time we look for a literal string of user tier equals tier 1 anywhere in the log line, and we add a new log attribute with a key of support.tier and a value of gold. We do the same thing for tier 2, of course that's silver, and tier 3 is bronze. The reason we can do this is because in OpenTelemetry, logs aren't just flat strings of logs. It's actually a JSON object. So you can have log content and the extra key value metadata that you need to add to the info. And that's what happens. You get the support tier in your observability backend. Okay, imagine you have either bought a new system off the shelf or you've got a new developer or a new team, and for whatever reason, they have messed things up. It's slightly different. They have user.tier equals tier 3, and you'll notice the enrichment in the collector isn't working anymore. It's not matching. And that's okay, that's by design. It's not matching the rule, but the question is, how do we fix this in the collector? We can't change what the developer has done. So it's very simple. It's a one-line change. Before we enrich the log with gold, silver, or bronze, we replace user.tier equals with user tier equals in camel case, and then our rules work. So this is what it looks like afterwards. We have now the correct camel case of user tier is tier 3, and lo and behold, our support tier enrichment works and it is bronze. We have a password in the log files. How do we solve this using the OpenTelemetry Collector? Well, actually, there's two potential ways we can achieve this. The first is using redaction. So here we're using the transform processor again, and we're looking at the log body, as always, and we're looking for the string the password is, and then any value. If we find that, we're just replacing the whole thing with stars. And as you can see, it works absolutely fine. The problem is, though, what if, password is capitalized, or it's pass space word, or some other variant? You're at risk of having PII or passwords or credit cards or whatever the case may be put into the logs and then stored in the back end, and that's not great. In my opinion, the better way is to actually use the filter processor. Now, filter, think about a water filter at home. When you put the water filter in that jug, it filters out impurities. So here we are saying, look for a regex for the word password case insensitively. And if you see it anywhere in the line, filter it out. Just completely drop that log line. Never store it in the back end. And for me, that's a better solution because yes, you're losing that log line, but you're not putting customer data at risk. So this would be my recommended approach. Now, one thing to mention, I have mentioned it previously, but ordering matters here. There's no point in doing all of the resource detection, the transformations, the batching, and then throwing the line away. Filter it first and then do all of the rest of your logic in the processors. I mentioned at the beginning that OpenTelemetry has two fields, the textual information and the numerical information. So this is what you're seeing in this table. The severity number goes from 1 to 24, and as you get higher, the logs get more severe. Now, we've all seen debug logs in production. They shouldn't be there, but they are, let's be honest. So how can we use the collector to filter out any logs at a certain level that we don't want? It's actually really, really simple. We use the filter processor to match any log records where the severity number is less than warning, and then we just, as the filter processor does, it just drops them. So now there are no more debug logs in production. Okay. Let's talk about organizational enrichment. So we know that file.log is owned by a particular team on a particular set of VMs, but the question is, how do we actually route tickets to them? How do we organize, cross-charging them for their log storage so that they only get charged what they consume internally? So the requirements here are that every log line from file.log must include a team name, a team contact details, and some sort of cross-charging code that we have internally in our company. Very, very easy to do. All we do is we add key value attributes onto each log line that comes from this file log receiver. So every time there's a new log line written to file.log, the file log receiver is going to see it, of course, and it's going to dynamically insert team.name as team A, team.email as team A at example.com, and the charge code as well. And then that's there. It is there. There's nothing else to do, and it hits our backend like this. Now, when it's in Dynatrace or your observability backend, you can now use this information to run workflows, to route tickets, to route Slack notifications to the right channels, and so on and so forth. It's a really simple way and a really quick way to start enriching your logs with really important whatever information that you might want. Now let's switch gears a little bit and talk about logs to metrics. So here you can see we have a log line and with a value of 200 in a field called field. So that 200 value would actually be really nice to chart on a time series or to store in a time series database or to alert on, for example. So how do we arrange using the collector to extract that value and do something with it as an actual metric, not as part of the log line? So we need to, again, read the log lines. We need to extract that value of field equals, and then we need to sum it up and send it as a metric. The reason we need to sum it up is, remember, the file log processor may well read multiple log lines at once. And if multiple log lines have a field, you need to add all of those values up. You can't just take the last or the first one. So for example, if it reads two log lines, the first one has a value of 200 and the second one has a value of 100, your field value should be 300. Fair enough, straightforward. But how do we achieve that? The first thing we need to do is use an operator in the file log receiver. And again, we're going to use the regex parser. We're going to look for field equals, and then that complicated regex there is just looking for any digits after the equal sign, and the brackets are just a capture group. So we're just saying grab any digits that are after field equals, in this case 200, and then the file log receiver will add that, as I say, as a separate attribute, as well as the log line will have an attribute called field_value, and that can then be summed up using the signal to metrics connector. And here we're saying treat that value as an integer and just sum all of those values and then send them out. Now I want to focus on this connector because it's the first time we've seen this. So look at these pipelines. We have the logs pipeline as usual, the file log. It's going to read the file logs and it's going to export to the signal to metrics something, the connector. Then the metrics pipeline that we've newly defined has a receiver of signal to metrics. That's because connectors are both exporters and receivers. It's a way to sort of connect multiple pipelines and transform the data. So if you, and then the metrics are actually sent out to debug and OTLP HTTP. But notice what this means. Look at this YAML snippet carefully. We are dropping the log lines. We are not pushing the log lines into our observability system. We're using the log lines, we're extracting the number, the metric, and then we're dropping the log and we're pushing the number into the backend. Of course, you could, where we've got in the logs pipeline, you could add OTLP HTTP and also send the logs. There's nothing wrong with that. Now, let's talk about CSV files. CSVs are everywhere in a large company. I wish they weren't, but they are. And they're actually very, very useful and contain organizational knowledge that you don't have in your IT systems. So look at these logs, for example. We've got lots of hello world logs with component equals and then some sort of value. Separately, on our hard drive somewhere, we've got a CSV file with component, responsible team, owner, and support tier. Now, as humans, we can quite easily see that, well, the component front end is owned by team A, Alice is the email, and tier 1 is the support tier, or the level of service that the front end gets. Middleware doesn't have any owners, and back end is owned by team B. And that information, we want to kind of smush both of these together and get that information into our backend systems. We want this, basically. Every single log line has been enriched with this CSV file. How? Well, actually, it's quite simple, and you've done most of it already. First, we do what we did before. We use the regex parser to regex out the component. So front end, middleware, back end, whatever, we regex that part out. And then we use the lookup processor from bindplane to load the CSV file and match on that field. So the way to read this, the context is looking in the attributes, and it needs to match the name. So where you have component in the CSV file, it needs to match that name in the attributes. And then, of course, we have the pipeline down below. We're looking at logs from the file log receiver. We are doing the lookup against the CSV file and enriching, and then we're pumping that out into our backend system. And that's what we get. We get enriched log lines. Very easy. So one thing to note, this lookup processor isn't part of any standard OpenTelemetry distributed collectors. It is built by bindplane, so you will need to build your own collector instance. So in summary, where are we? The collector is an enormously powerful component, as you've seen. We've only touched on logs, and you can already see what is possible with this collector sitting in the way. It should be, in my opinion, part of every modern observability setup. It's just too powerful not to have at your disposal. And everything you've seen, all of the examples, all of the YAML, all of the code, you can try all of this in a browser. If you follow that short link, it's going to bounce you across to a GitHub web page effectively, and if you click a button, it'll spin up a new tab. All of the code, all of the environment will start up, and you can try this out, and you can also see all of the code behind it. It's all open source. Now, that's apart from the lookup processor, because it wasn't quite there when I originally wrote this setup. So I did a separate YouTube video if you want to have a look at the lookup processor and dive into depth as to how that is all set up. So thank you so much for your time. Thank you for the opportunity, to the organizers for letting me present. I'm Adam Gardner, the lead developer advocate at Dynatrace. See you soon.